All right, everyone, thanks for joining. We got a sellout crowd here, so obviously robotics is top of mind, I think, for a lot of people. Thanks for coming back from lunch. We have an absolutely distinguished group of investors here, but what's crazy about the robotics space is just a couple of years ago, there was no real robotics investors at all if we looked like 7, 8 years ago. And now we're seeing dozens of startups being funded. Several have grown to be quite large. We have several large exits in the space. And so I'm looking forward to the panel today. I'm going to want to start out. We obviously have a lot of founders in the room, some of whom who are considering starting a robotics company. What kind of backgrounds do people need today? And I'm going to start with Cyril on this one. What kind of backgrounds do people need in the robotics space today? Do you need to have a robotics PhD to do well in this space? Is that the critical kind of skill?
Yeah, I think things have been evolving quite fast over the past few years. I'd like to take the example of one of the most well-known robots that kind of kickstarted everything, called PR2, a few years back. And the team that built all of this was literally rocket scientists, and maybe you call them roboticists as well. What's been really interesting over the past 2 to 3 years is that the evolution of technology and building on the shoulders of giants as well of those technologies really has kind of changed, I think, the profile of the founders and the group of founders that can build a robot at the first place. I think the technicalities of it, of course, are still extremely important. But the more we look at robots, the more we don't look at the technology, we really look at the applications.
And Helen, you're also sort of at the seed stage with Lemnos Labs. I mean, what are you seeing as a pattern for the backgrounds of founders these days in the robotics space?
I think the ideal founding team is going to consist of that roboticist or technical leader. You're also going to need some domain expertise around whatever vertical that you're considering selling into. Selling robotics is actually really hard. It often involves multiple people agreeing to a sale, which could be somebody who's head of security, head of IT, head of facilities, to all come together and say, yes, this works for us.
When you look at the starting profiles for all of your companies, are they coming more from the hardware innovation side, or are they coming more from the software side? Obviously, Claire, you're coming from NVIDIA, so you obviously have a lot of people coming in on the hardware side. But what's sort of the patterns you're seeing in that world?
Well, a robot is really an assembly of hardware and software, and the more we push intelligence to the hardware by, for instance, flashing or deploying a neural network inside the sensor itself, the more the frontiers between the hardware and the software are blurring. And that's what's beautiful about robotics. It's that there's no magic answer to build a robot. It's really an assembly of a lot of different skills that have to work very well together in order to solve a specific problem.
And Peter, you as well, I mean, you come from a hardware background, but you're also increasingly looking at different software layers in this space. I mean, what are you seeing with Playground?
Well, I think the scope of what a robot is broadening, right? We consider it to be anything with sensing and actuation. Mm-hmm. So a camera is much a robot as an atlas, a city is a robot. So the breadth of disciplines required to animate those pieces of technology, to attach the sensing and actuation to intelligence, is actually rolling in a whole bunch of software disciplines that haven't actually been closely correlated with robotics as yet.
Mm-hmm. And let me ask you, I mean, one of the challenges is you have to bring so many different components together in order to make a robot, whether it's sensing and perception, and then GPUs and some of the technology behind that, arms and articulation to be able to actually act in space. Are you seeing improvements for early stage startups to be able to sort of get their MVPs into market, to actually put those components together quicker so that their first kind of demo robot isn't the Series B, but something else?
Yeah, I mean, I think you want most of your capital to go into new technology, not re-engineering Shaky the robot from 50 years ago. Yeah. And I think probably 90% of the capital that goes into robotics now goes sideways on stuff that just isn't important and isn't part of the key application. So there's a huge opportunity for platforms to make that capital more efficient.
And do you see that pattern for the other panelists as well?
Well, it's quite, I wouldn't call it the prehistoric, era of robotics, but we're still at the very early innings. If you, there are a few things that haven't happened. Of course, you don't build an iPhone with an Arduino board. So that's, NVIDIA and others are working on much more powerful technologies and microprocessors that will actually suit the needs of robots, which literally were not available 2 to 3 years ago. And it's the same surrounding all the sensors. The motors, for example, the resolution for motors is probably more akin to a Game Boy than an HD TV today about how much control you can have over it. The battery technology is just all of this actually needs to continue to move forward, and then we probably will have our Macintosh moment of the robotics, which we haven't seen yet.
And Helen, what about you?
We're starting to see a lot of platform companies that are solving part of the stack that maybe they are uniquely suited to do, and a lot of our companies are struggling with. And it's often our portfolio founders who bring these companies to us with, hey, they solve this piece really, really well, and they're doing it, for these 5 companies. Is that an interesting investment? And I think we're starting to get to the point where yes, we are seeing fleets of robots in the field doing interesting things. We're a long ways from tens of thousands, hundreds of thousands, millions. But some of these companies, if maybe it's a component that they do really well now, can start to slice across in different verticals.
And how do you think about, there's sort of a chicken and egg problem, right? Like, let's say you build a great arm. You need robots to actually use those arms, but those robots need the arms in the first place to be relevant to their particular applications. Like, how do you, as an investor or from the NVIDIA perspective, like as all your customers, how do you get all the sales processes in place here in the right order?
So yeah, I think it's a fascinating problem, because this is really, I've been doing robotics for more than 15 years, and that's the recurrent pattern is this chicken and egg problem. Is how do you, as a startup, for instance, how do you survive the first 2 years by trying to put all this hardware that doesn't exist anywhere else together to even just create a demo robot? And so the reality is that if we look at the, for instance, cell phone, before the cell phone were so democratized, and we have a smartphone now everywhere, an IMU was extremely expensive. And the simple fact that we found a single product that concentrates all this hardware and that we can mass produce completely changed the prices of like IMU, magnetometers, and all of that. And suddenly we started seeing software around it, and people started building on top of it. And today, very interestingly, we see the same thing happening in self-driving cars. Because finally, self-driving car is a robot, right? It's actually doing something very useful, so we call it self-driving cars, what it's actually supposed to do, not robots. But all the startup working on, and companies working on self-driving car, they all need the same sensors. And it turns out these sensors are also the one we need for robotics, which is fantastic, because by the movement that's happening in the economy nowadays, we can actually capitalize on it, and we can bootstrap a lot of very brand new application in terms of robotics, things that would not be possible to work on if we didn't have this suddenly momentum on the hardware.
Yeah, it would be awesome if a Velodyne 128 cost the same as a cell phone IMU. So we have some way to go. But there's definitely a sense that robotics is like cell phones in 2005. So what lies ahead are some normalizations of platforms and an explosion in hardware, because all of a sudden, broader sets of people can build really exotic hardware and very capable hardware if they're not hamstrung by the limitations of software. And if you look at industrial arms today, they're amazing machines. They're incredibly accurate. They're only differentiated on how bad the software is right now. So I think there's some real opportunities to go through that same watershed that phones went through.
We're talking about autonomous cars. robots today are very kind of independent. They don't really interact with each other, or they interact, spatially, but they don't interact in terms of data or sort of any sort of software layer. I mean, are you starting to see how robots are actually communicating? I know, Peter, you've spent quite a bit of time thinking about this sort of, network approach to robotics.
Yeah, I mean, I think we try and solve autonomy very anthropically, and that we try and make these things sentient and independent. And I think they work much better when they can collaborate with each other and cities. We can't read each other's minds or see through each other's eyes, but cars can do that, and robots can do that. And so if they're talking to themselves or talking to cities, they can do superhuman things, and we know how to write that software. So thinking about robots in aggregate, thinking about these applications in aggregate, changes the way you think about the platform.
Mm-hmm. And are you seeing any sort of open source or kind of open standards around robotics? I mean, is it too early to go on some of this sort of stuff? I don't even know if any of you are seeing it, so the answer might be no. Are there any sort of patterns in that category?
There's a lot of open source software. ROS is a very good example of high-level software. Mm-hmm. But we also see standardization at the sensor level on like what kind of data do we need from the sensor, which is very interesting because we need to be able to leverage very stable blocks to build a robot, because building a robot is extremely complicated. And so you have to standardize somewhere in your stack. And when you can standardize on the image format, for instance, or on the detection that are coming directly from the sensor, you are able to exchange and compare different approaches, different sensors, with the same results on your side, on the software side, or on the decision-making side. And that's a very interesting trend.
I will say there's one big missing piece, which is there's standardization of knowledge and representations of knowledge and experience are completely missing. So we have JPEGs and videos so we can train neural networks to do perception tasks. We don't have standards for robotic force torque sensing, or we don't have standards for RL learning of arms. And so in order to, it's not just the open source software that needs to be there, it's these common representations of knowledge so other people can train on data that you collected and you can build that corpus. Like JPEG is incredibly important for robotic perception, and everything else is missing so far.
Let me ask you, Helen and Cyril, I mean, both of you, we're talking about collaboration, have sort of accelerator models or co-location models, and Peter, you as well with Playground, you're putting founders together, they're learning from each other. I mean, are there sort of lessons learned that are being shared from those sorts of groups?
Yeah, there's definitely synergy when you put a lot of companies solving different problems, but working on similar pieces of technology. They can do design reviews for each other. They can share customer sales experiences, I think all beneficial to the group.
And Helen's startups are mostly in San Francisco, is that correct?
Not actually. So we'll actually invest across the US. This is something that we've become more open to recently. I think there was an article in The Economist earlier in the week that maybe the
little Peak Valley, yes.
And that's definitely something that us and other investors are becoming more open and even looking outside of the valley more aggressively.
Absolutely. And Cyril, I mean, you've been a heavy investor, particularly in China and Asia, more broadly, and around the world. I mean, what are you seeing? I mean, do you believe in sort of this Peak Valley hypothesis, or is the robotics industry still really centered here?
So we have a fairly large office in Shenzhen, and what's been great was to definitely see the same thing as Helen, as you have pools of technologies going together. They can definitely stay abreast about the latest technologies, and there are still not economies of scale on volumes and whatnot, but we also have some alumni from 4 or 5 years ago that now have fleets of hundreds of robots out there, and so it really helps to figure out the path, and it's not, the technology is great, it makes things advance, but I think the next frontier is definitely to find what customers really want, which is a common issue with technologies looking for a problem, and robotics are a technology as we understand it, not really an industry, and it's really important to confront it to reality as fast as possible.
I want to follow up on that point specifically. Who are we designing robots for? when you think about customers, I mean, who ultimately are the customers? Is it enterprises? Are we talking consumers? Is it, into the supply chain? And anyone who wants to sort of engage on that, feel free to stand up. But who are the customers for these sorts of technologies today?
Yeah, well, you can definitely divide them between consumers and robotics, which everybody has seen or heard of today, and interacts or trying to interact with you. The first one, I guess, the first real consumer robotics company was iRobot and having a Roomba around. But over the past few years, the thing has been beefed up a bit. You probably have seen some humanoid robots, educational robots have been coming up, and robots that don't look like robots, like for example, Ninebot and their kind of scooters that run around on their own and do surveillance now. So that's the consumer part. But where the most exciting things are happening are obviously on the B2B side, and where we hear the most about it is in manufacturing and anything that robots will take over jobs and whatnot. And it's definitely true, and it's actually a good thing, because where we think the bigger opportunities are in the 3Ds, the dull and dangerous and dirty jobs essentially that can be replaced by robots.
And do you see, this is for Helen, you have a company here in San Francisco that's doing the robotic hamburgers. This is sort of like a B2B2C kind of model. I mean, is that something that you're seeing as well in the market, or is that sort of like a one-off play?
No, we actually did something slightly similar that we can't disclose yet, but I think that's a model of type of robot that is a long ways away from being a personal consumer thing that you have in your house. But in the meantime, you can set up a retail location that can delight lots of consumers. Yeah.
One of the biggest questions I have about robotics, so we're talking about representations, we're sharing data. Is this a winners-takes-all market? When you look at kind of the robotics technologies, perception is machine learning, so the bigger the data sets, the better you do. Waymo has driven more than 1 million miles or something along this line. Is that something that you're worried about? Is it a winner-takes-all, or is it possible to have 50 different stacks?
Well, I think over time, collecting data to do interesting things, collecting skills for robots is going to be incredibly valuable. There is no robot app store. A robot app is intelligence and experience the robot has. And so being able to use that knowledge across heterogeneous devices and make it repeatable, I think is a real valuable thing to have. There's a lot of tooling that needs to get built before you can do that. But at the limit, to be able to take knowledge, transmit it to various robots, and have them wake up smart to do new things is, it's plausible. You just need to do some underlying work to make it real.
And Claire, you've also thought a lot about this sort of topic as well. Do you see it as a winner-takes-all market from the NVIDIA perspective?
So that's a very good question. I think, so when I'm French, obviously. So when just in case you didn't know it, he's French,
I'm not.
by the way. It's like, this is the French invasion. But when I arrived here, I was extremely, as an engineer, I was blown away by the technology, the power of dreaming about technology, not products, technology, about having a startup, of building like the best robots ever, or the best technology ever, and then what? That's the question I never asked myself. So then for what? And the more I worked at Google, I worked at Uber, I worked in different companies, and the more I worked on this difficult topic, the more I realized that technology by itself comes, like delivering a technology to a market comes at a price and comes with a responsibility. And for instance, for self-driving car, there's something that really annoys me, which is all these companies are competing to get the best self-driving stack ever. But the ultimate question is that if there is really one stack much safer than all the other one, why wouldn't all the self-driving cars have the same stack? Why wouldn't it be mandatory to all have the same stack instead of like having dangerous stacks on the market? And I think this is really the reason why I joined NVIDIA, because NVIDIA is a platform provider. We provide platform and building blocks for others to build on top of it. So every technology that we develop the goal is not to capitalize on it and to keep it for ourselves. It's really to enable other companies to build on top of it. And for very complex topic as robotics, I don't think there is really an option. And I think it would be actually pretty sad if only one company in the market would have all the knowledge, all the power, and would not let any third-party entity to have a look at the technology and to criticize and to make sure that the safety is in accordance with our economy or with our, I mean, basically we would have a third party able to look at it. So I think it's very important that we democratize as much as possible this technology, not because it's cool, but because we need multiple actors to make the right decisions. A single entity cannot make the decision alone.
And on the democratization, I mean, that segues into, I think, an important question. Obviously, automation, in many cases, costs jobs, whether it's hamburger flippers or car drivers or pick and pack in an Amazon store. You know, is there going to be another kind of political dimension going on here, you know, regulations or challenges as you sort of build these technologies?
Yeah, look, I think that robots destroy occupations, not jobs. I think there's plenty of opportunity for automation to continue to create wealth. It does tend to concentrate it, so we have to do something about that. But you know, I think there are extraordinary opportunities for agriculture, extraordinary opportunities for manufacturing and the future of retail that don't have the humans to do the work. And I think there's an opportunity for robots to fill that gap. And I'm not concerned about 90% of the jobs are going away in 2 years because it's nonsense. And I think that transition will be more measured, but we have to be, I think concentration of wealth is one of the biggest problems we need to solve.
Yes.
I think robots also can improve lots of lives. One of the great things about Creator is that it's a $6 burger. You don't need to work in tech to pay $6 for a hamburger. Mm-hmm.
And I think that's actually, just to go up on that, when you look at the hamburger robot or actually any robot, I think you have to see it as more of something that creates jobs. It's a company on its own in a way. And you could imagine that you know, with all the efforts that are made on the pricing, as you know, technology gets cheaper anyway and faster and better, the cost for building those machines is becoming just irrelevant, which means that everybody could own one or at least could lease one, and it can be very powerful. I think like we've invested in a company called AvidBots, which does industrial cleaning for airports and for shopping malls and whatnot. And today they are relying on networks of distributors, and you can imagine that this thing just rolls around and cleans stuff. And so, you know, you and I tomorrow could just buy one and create our own job this way and create a new market and etc. And you can think about this with every single robot. Essentially, it's just a business on wheels, if you will.
We're almost out of time, so a quick classic robotics panel lightning round. How long until we see autonomous cars on the road? And let's say 10 to 15%, not a majority, but let's say, you know, a decent size of the number of cars that you see on the road would be level 5, sort of fully autonomous cars. Peter?
30 to 50 years.
30 to 50 years. Helen?
10.
10.
Oh, predictions. I'll say 10, and it will be in China, and it will be a top-down decision.
It'll be a Belt and Road, yes.
Removing pollution entirely out of China.
Exactly. Claire?
All right. Do you mean self-driving cars on the street, passenger cars with
passenger
consumer
cars? Yeah.
All right. I agree with Cyril.
10. In China.
In China.
In China.
and I agree with Peter in the US.
Absolutely. All right, everyone. Thank you so much for joining the panel. I hope you had a good time.